Back in October 1989, a NASA spacecraft named after the famous astronomer Galileo was launched into space, beginning a 14-year mission that would reveal the solar system's largest planet like never before. The mission involved over 800 people from multiple countries and achieved many firsts, including being the first spacecraft to orbit an outer planet, the first to deploy an entry probe into an outer planet's atmosphere, and the first to closely image an asteroid. Hello and welcome to ZE. Please, don't forget to subscribe and hit the bell icon. Galileo's journey to Jupiter started when it was released from the cargo bay of Space Shuttle Atlantis while in orbit around Earth. Since the spacecraft did not carry enough fuel for a direct trip to the giant gas planet, it was set on a cleverly designed flight path that would take it past Venus once and Earth twice, using a technique known as a gravity assist maneuver to increase its speed and propel it outward into the solar system. In February 1990, Galileo reached Venus, providing the first opportunity to properly test and calibrate its scientific instruments. It studied the thick Venusian clouds as it swung past the planet, sending back fascinating images of its toxic atmosphere. This almost eerie image exposes the planet's thick clouds as they circle above a scorching surface. The image, captured 5 days after Galileo's closest approach, was taken through a violet filter and colored blue to enhance contrast, revealing the cloud structure in greater detail. After gaining a boost from Venus, Galileo returned to Earth for 2 more gravity assist flybys, the first in December 1990. During this flyby, Galileo captured a magnificent true color image from around 1.5 million miles, 2.4 million kilometers, away. The image shows Africa stretching upwards from the center of our majestic planet, while the sunlit continent of Antarctica sits at the bottom, slightly shrouded by swirling clouds. Close-up images of Earth, such as this bird's-eye view of Antarctica during the day, with the darkness of night rolling in from the side, were also captured. The thin envelope of Earth's bluish atmosphere following the curvature of the planet serves as a reminder of our fragile existence. In October 1991, Galileo clipped the edge of the asteroid belt, a vast region between Mars and Jupiter. Within this region, Galileo made history by snapping the first ever close-up images of an asteroid named Gaspra. This 11-mile-long, 18-kilometer-long asteroid is heavily pockmarked, suggesting a relatively recent origin. The sun's light illuminates the asteroid's surface features, casting dark shadows across its scarred, cratered landscape. The lack of larger craters suggests that Gaspra may have been part of a larger body that was broken up during a catastrophic collision. In December 1992, Galileo completed its second flyby of Earth, boosting its velocity for the last time and saying goodbye to its home planet forever. Now, with enough speed to start its long journey to the outer solar system, Galileo headed towards Jupiter. Before reaching the gas giant, it encountered one more object in August 1993, the asteroid Ida, which was discovered to have its own moon, later named Dactyl. Ida, about 35 miles long, 58 kilometers, and its 1 mile wide, 1.6 kilometer wide companion likely originated from a larger object that broke apart in the past. After passing Ida and Dactyl, Galileo continued on its journey, eventually leaving the asteroid belt and entering the final stages of its trip. In July 1994, the spacecraft was perfectly positioned to watch 21 fragments of Comet Shoemaker Levy 9 crash into Jupiter, capturing stunning images of the impact. Galileo visited Venus, swung by Earth twice, and encountered 2 asteroids, witnessing a Comet versus Jupiter showdown. After a journey spanning 6 years and 2.3 billion miles, 3.7 billion kilometers, Galileo finally arrived at Jupiter. In July 1995, it released a small atmospheric probe as it approached Jupiter. The probe made a solo flight into Jupiter's atmosphere, descending for 95 miles, 153 kilometers, before being vaporized. Although it wasn't equipped with a camera, it collected direct data on Jupiter's weather, recording wind speeds of up to 450 miles per hour, 724 kilometers per hour, and detecting massive thunderstorms. In December 1995, Galileo successfully entered orbit around Jupiter, marking the start of its primary mission. Over the next 8 years, it orbited the gas giant, capturing thousands of incredible images of its mesmerizing atmosphere, including the famous storm, the Great Red Spot. The orbit also allowed close-up flybys of Jupiter's largest moons, starting with the icy world, Europa. NASA's Galileo mission, launched on October 18, 1989, was primarily aimed at studying Jupiter and its moons. However, the spacecraft's journey also included flybys of Venus and Earth, offering scientists unprecedented opportunities to gather valuable data about these planets. This essay explores the significant observations and discoveries made by Galileo during its encounters with Venus, Earth, and Jupiter. Venus, a closer. Look at Earth's twin. Galileo's first planetary encounter was with Venus on February 10, 1990. Although Venus is often referred to as Earth's twin due to its similar size and proximity, its environment is vastly different. During the flyby, Galileo used its instruments to study Venus's atmosphere and surface. The spacecraft's near-infrared mapping spectrometer, NIMS, provided detailed data about the planet's thick cloud cover and its composition. One of the significant findings from Galileo's Venus flyby was the detailed mapping of the planet's cloud structure. The spacecraft detected variations in the cloud composition, revealing insights into the complex dynamics of Venus's atmosphere. The data suggested the presence of unknown compounds and particles that contribute to the reflective properties of the clouds. This information has been crucial in understanding the greenhouse effect on Venus, which results in surface temperatures hot enough to melt lead. Earth, a home planet. In perspective, Galileo's two flybys of Earth on December 8, 1990 and December 8, 1992 served dual purposes. They provided gravity assists to propel the spacecraft towards Jupiter and allowed scientists to calibrate and test its instruments. These encounters offered a unique opportunity to observe our planet from a different vantage point. During the flybys, Galileo captured stunning images of Earth and its moon, providing a fresh perspective on our planet's weather patterns, land masses, and oceans. The spacecraft's instruments measured Earth's magnetosphere, radiation belts, and auroras, contributing to our understanding of these phenomena. One of the most notable achievements was the first detection of life on Earth from space. Galileo's instruments detected the spectral signatures of oxygen and methane in the atmosphere, along with the distinct red edge of vegetation, indicating the presence of plant life. This experiment demonstrated the potential of remote sensing techniques for detecting life on other planets, a method that could be used in future extraterrestrial explorations. Jupiter, unveiling the giant. The primary objective of the Galileo mission was to study Jupiter and its moons in detail. The spacecraft arrived at Jupiter on December 7, 1995, and began its extensive exploration of the gas giant and its diverse system of moons. Over the course of its mission, Galileo provided groundbreaking insights into the largest planet in our solar system. One of the most significant discoveries was the observation of Jupiter's turbulent atmosphere. Galileo's imaging systems captured detailed images of the planet's cloud formations, storms, and the iconic Great Red Spot, a massive storm larger than Earth that has raged for centuries. The spacecraft's instruments analyzed the composition of Jupiter's atmosphere, revealing the presence of ammonia clouds and complex weather patterns driven by the planet's rapid rotation and internal heat. Galileo's exploration of Jupiter's moons yielded remarkable findings. The spacecraft discovered evidence of subsurface oceans on Europa, Ganymede, and Callisto, three of Jupiter's largest moons. These oceans are believed to be hidden beneath thick ice crusts and could potentially harbor conditions suitable for life. The detection of a magnetic field around Ganymede, the largest moon in the solar system, was another groundbreaking discovery, suggesting the presence of a liquid iron or iron sulfide core. Galileo also provided detailed data on volcanic activity on Io, the most volcanically active body in the solar system. The spacecraft observed massive eruptions, lava flows, and volcanic plumes on Io's surface, offering insights into the moon's intense geological activity driven by tidal forces from Jupiter's gravity. Conclusion. The Galileo mission was a monumental achievement in planetary exploration, providing invaluable data about Venus, Earth, and Jupiter. Its flybys of Venus and Earth not only aided in the spacecraft's journey to Jupiter, but also enhanced our understanding of these planets. The detailed study of Jupiter and its moons has profoundly impacted our knowledge of the gas giant's atmosphere, magnetosphere, and the potential habitability of its moons. Galileo's legacy continues to influence future missions and the quest to explore the mysteries of our solar system.